All right, everybody, we have one more section to do for this chapter, and then we'll take our test. This section has to do with something that we call concentration. So concentration. Okay, concentration. Concentration, we're talking about how much stuff do you have in your mixture, right? The higher the concentration, the more stuff you have in the mixture, okay? Now sometimes concentration is really easy to see, right? If we go back to our mixtures from before, so this is our suspension, okay? I can mix that up and that's gonna settle out fairly quickly. This is our suspension. Now it's really easy to tell which suspension has more stuff in it because you can see it, right? If I were to add more sand to this, it would be really easy to see that one has more concentration than the other because you can see the different parts because they separate. One of the other mixtures we looked at the other day, a colloid. Okay, here's our colloid. Again, it's really easy to see the different concentrations. If I were to add more cornstarch to the water, you would be able to see it would be a darker color, it'd be more opaque, less translucent, and you would be able to see the concentration. When it comes to something like a solution, right, where you can't see the different parts of our solution, it's really hard, or it's more difficult to determine concentration just by looking at it. It's almost impossible to see concentration just by looking at it. And so what we need for concentration is we need a way to express how much stuff we have when we can't see it, okay? And that's what we call molarity. Okay, molarity. Molarity is a way to express concentration, to say how much stuff we have with a solution, because you can't always, it's almost impossible to see how much stuff you have, right? How much stuff is dissolved in the water. We express that in terms of molarity. And what molarity is it's moles of your solute. The solute, that's a word from Quizlet. Solute is the thing that's dissolved in the water. So for example, in our solution over here, in this solution here, I've got salt dissolved in the water. Salt would be my solute. So I have the moles of my solute divided by the liters of my entire solution, of the entire mixture. So this one here, if I take this solution here, I've got about 350 milliliters total solution. So I would take how many moles of salt I have divided by 350 milliliters. Of course, it needs to be in liters, so I would just move the decimal point over. Okay, and then, so this is molarity, and the variable, the unit that we use is a capital M. Okay, a nice big capital M, that's a horrible M. A capital M is what we use to represent molarity. Okay, this is all on Quizlet, so you can go double check that. Let's go through a couple of questions from the homework, and I can give you an example. So first, I'm going to make up an example and kind of show you how this works, and then we'll go into some of the questions from the homework. So let's pretend that we have, let's say 0.5 moles of sodium chloride. Okay, let's say I have 0.5 moles of sodium chloride, and that's how much I put into my mixture. And I mix it all up, and we'll just use the volume I just looked at, 350 milliliters of total solution. Okay, before we can put this into my equation of moles over liters, I first need to turn this into liters. And there are 1,000 milliliters in a liter, so I'm just going to move the decimal point over 3 times, and that becomes 0.350 liters of my solution. And this is the volume that I'm going to use in my equation. So remember, molarity is moles of my solute, which in this case is sodium chloride, my salt, divided by the liters of my total solution. So now I can put in some numbers to that. 0.5 moles over 0.350 liters. And then, now that I have this, I just put it into my calculator. So I get up my calculator, my brand new Casio calculator, by the way. 0.5 divided by 0.35 is going to give me an answer of 1.43, and then the capital M is my unit there, okay? And the way we say this is 1.43 or 1.43 molar, right? We don't say molarity, we say molar. 1.43 molar solution of sodium chloride. So for units for this, I need both the capital M and the chemical formula for my solute, right? Sodium chloride or sugar or whatever it is, right? Whatever is dissolving in the water, I need to put the formula here. Okay, so that's an example. Let's go ahead and go through one from the homework to give you kind of an idea. So let's look at number 1. So this is page 270. This is the last page in your packet for chapter 7. Or sorry, chapter 8. This is chapter 8. So it's page 270. Let's look at number 1. So number 1 says that vinegar contains 5 grams of acetic acid, and it gives us the formula. In 100 milliliters of solution, what is the molarity of acetic acid in vinegar? So I'm going to first write down the things that I know. I know that I have 5.0 grams of acetic acid, which is CH3COOH, and it's 100 milliliters total solution. And right away, I know I need to turn this into liters. So that's 0.1000 liters, 0.1 liters. All right. Now in order to answer this question, right, it's asking what's the concentration, what's the molarity. I know I have to do moles over liters. Well, I don't have moles, I have grams. So this is where we need to remember what we did last chapter, and how do I turn grams into moles? I'm going to show you one way of doing it that makes sense for me, that works for me. If you have another way that makes sense for you and you can consistently get the right answer, then go ahead and do that. If you're not sure how to do it, I would recommend trying it this way. Because if you do it this way, I promise you'll never, ever, ever make a mistake. So I'm starting with grams. I would recommend that when you do this, just ignore the numbers. Okay? Actually, let me get a darker color here. That green and yellow doesn't seem to be showing up. So just ignore the units, or sorry, just ignore the numbers. Only use the units. So I'm starting with grams, and I need to get to molarity, which is moles over liters, right? That's my molarity. That's a horrible M. I'm struggling today. These are the units that I need to get to. This is where I'm starting. Okay? Well, in order to get grams to go away, right? Think about reducing fractions. If I have a fraction here of, let's say, 2/3, and I multiply it by 1/4, okay? Don't worry about what the answer is. But we multiply fractions. Think about how we do this. We multiply fractions by going straight across. So this would be 2 times 1, which is 2. 3 times 4, which is 12, I can reduce that to 1/6. So I can reduce it at the end, or I can reduce it at the beginning. If you remember back to math class how to do this, I can reduce diagonally here. And I can say 2 and 4 are both divisible by 2. That becomes a 2, that becomes a 1. I multiply straight across now, and I get 1/6. Same answer, I'm just reducing at the beginning instead of at the end. We're going to use that same idea when we're converting units up here. So grams, the way I don't have grams in my answer. So I have to get grams to go away. I've got to get it to reduce. I've got to get it to cancel. Whatever you want to call it, I don't want it. So I have to put grams on the bottom of my fraction here. It's the only way that I can get them to reduce. And I know that grams and moles have a relationship, right? That's what we talked about last chapter. Grams and moles have a relationship. Or not last chapter, earlier this section. I can look up on the periodic table and see the relationship between grams of acetic acid and moles of acetic acid. I can look that up, and we'll do that in a minute. All right, so that means grams are going to go away. I'm left with moles on top. That's what I want, so I'm good there. The only thing I need is I need liters on the bottom. Well, here we go. I'm just going to put liters on the bottom. So I've got moles on top, liters on the bottom. I know that my units work out. So I know that when I put numbers in here, I'm going to get the right answer. I mean, assuming I put it in my calculator correctly, but I'm going to get the right answer because my units work. So let's go ahead and put in some numbers then. So the number here that I'm going to put in is 5, because that's the number I start with, right? That's the number up here that they tell me. This relationship here I need to look up on the periodic table, and we'll do that in a minute. And I know that I have 0.1 liters. I just found it up here. So I'm going to put that down here. Now sometimes it bothers people that there's nothing up here on top of this fraction. If you're one of those people and it bothers you that there's nothing on top of this fraction, go ahead and just put a 1. There's no unit up here because all of the units that I have already are in my answer. So I don't need a unit here. Okay? All right, so let's go ahead and figure out the relationship between moles and grams of acetic acid. Well, we're just going to look this up on the periodic table and add up all of the molar masses from my formula. So from my periodic table, I can look up and I can see that, let me grab a color here. I can see that I have 2 carbons. So whatever the mass of carbon is, I'm going to multiply it by 2. I have 4 hydrogens. So whatever the mass of hydrogen is, I'm going to multiply it by 4. And I have 2 oxygens. So whatever the mass of oxygen is, I'm going to multiply it by 2. And then I'm going to take all this, I'm going to add it up, and that's going to be the mass that I'm going to put here with my grams. So let's look it up. Carbon is 12.011. Hydrogen is 1.008. And oxygen is 15.999. All right, so I'm going to go ahead and grab my calculator, and let's add these up. So 12.011 times 2 plus 1.008 times 4 times 2 gives me 60.052. Remember, this is grams. All right, well, since this is grams here, that tells me right where I need to put it. I'm going to put it right here. And that's the number of grams in every mole. So what number do I need to write up here with the moles? I need to write a 1. Because 1 mole of acetic acid is 60.052 grams. Now that I've got my equation filled out, now I can just put it in my calculator. All these numbers on top, I multiply, and I divide by all the numbers on the bottom. So I'm going to do 5 times 1 times 1. I'm going to assume you can do that in your head. Divided by 60.052, divided by 0.1. I need to do divided by both of these because it's on the bottom of the fraction. And that'll give me an answer of 0.83. And again, my units are molar, capital M, And I have to write the formula of my solute. Acetic acid, CH3COOH. This is my answer. If I just write 0.83, that doesn't mean anything. Doesn't have a unit. If I just write 0.83 molar, well, 0.83 molar what? What's your solute? What's dissolved in the water? I don't know. You haven't told me. I've got to have all three parts. I've got to have the number, molarity, and the formula for my solute. So that's the last section. That's all of the new stuff for our chapter. Be looking for the chapter test. It will open up later this week. If you have any questions, feel free to email me. Look me up on Google Hangouts or Remind. Or we'll have a Google Meet, again, every day from 10 to 12. So have a great day, and I'll talk to you guys later. Bye-bye.